Hi, and welcome to another lecture, which is on module number 8, which is about infrastructure threats and security monitoring. Now, in this lecture, we'll be diving into the world of network level attacks with a special focus on the category known as on-path attacks. Now, these are particularly different kind of methods by which the attackers can intercept and manipulate the communication between unsuspecting parties. Now let's explore some of the most prevalent forms of on-path attacks to better understand how they work and what can be done in order to mitigate the attacks. Now, since we are talking about it, it's also called on-path attacks, which was previously known as man-in-the-middle attacks. It occurs when the attacker inserts themselves into the communication sessions between people or systems. The goal is to intercept, manipulate, or steal the data. Now, these attacks are sophisticated and can be difficult to detect, making them a dangerous threat to confidentiality and integrity of the data. So that's what we are explaining over here also, that the attacker would secretly intercept and would possibly alter the communication between the two parties who believe that they are directly communicating with each other. Now, there would be different components of it, like interception, modification, or injection. Interception means like capturing the data which is flowing between the two parties. So they can have Wireshark or any tool like that with the help of which they can capture the packets. Modification could be like they could alter the information before it is passed on, or injection may be that they'll be sending malicious data responses to both parties. Example could be that an attacker can intercept the communication between a user and their online banking service to steal the login credentials and manipulate the transactions, etc. After that, we have session replay attacks, an attack that involves capturing and retransmitting valid data, typically sessions or transactions, to impersonate one of the entities involved in the communication. So in this scenario, an attacker can capture a valid data transmission such as user login sessions and then reuse it to gain unauthorized access to the trusted resource. These type of attacks can exploit the validity of the session token by duplicating it or by personating the user, but it can also hijack the user session by gaining the access to the private data. So the components could be that it could capture, recording the session between the user and the service, or replay by reusing the captured data at a later time to gain unauthorized access. Example could be that an attacker can capture a user login session token by reuse it by the gain unauthorized access to the user account without needing the password. Then we have man in the browser, which we call it as MITB as well. Now, this is a form of man in the browser attack, is specifically to target the vulnerabilities in a web browser to manipulate the online transactions. So the tactic involves that an attacker using a Trojan horse or maybe a tool like that, with the help of it can actually infect the web browser. The malware then modifies the web page transmission content or inserts additional transaction, all in a completely covert fashion, invisible to both the user and the host web application. Now, this could be used to divert funds, harvest credentials, or to alter the transactions between the parties or the details of the financial applications, etc. So its components could be a browser compromise using a malware to take control, or the transaction tampering by modifying the transaction details in a real time without the user knowledge. Now, example again, during the online banking session, a malware into the browser changes the recipient's account number and the amount and the transaction entered by the user, then redirecting the funds to the attacker's account. Then we have another thing here which we call as DNS poisoning. But in this session, we'll be exploring two significant types of DNS attacks that can compromise the integrity of the network communication: DNS poisoning and DNS hijacking. So we are covering DNS poisoning here, and later we'll be covering DNS hijacking as well. Understanding these attacks is crucial for implementing effective security measures to protect our networks. So first, try to understand what is a DNS attack. DNS attack exploits the domain name system, a crucial component of the internet infrastructure that translates the human readable domain names into machine readable IP addresses. So when a DNS is compromised, it can disrupt and intercept the internet traffic, leading to a severe security implications. So what happens in a DNS poisoning is that a cyber attack in which corrupted domain name system data is introduced into the DNS resolver cache, causing the name server to return an incorrect record, for example, the IP address. This results in a traffic being redirected to the attacker computer or the destination. So in order to explain it in a different way, we can say that this attack involves the introducing of a corrupt data into the DNS resolver cache, causing the resolver to return an incorrect IP address, diverting the traffic from the attacker server, since there are DNS tables. And if someone is poisoning those DNS tables, so if you were going to Facebook before and there was a right entry for it, you will be going to DNS. You'll be going to Facebook. But if they have modified the entry on DNS tables to a different IP address, so instead of going to Facebook, you'll be landing on a different website. Now, its impact could be that users may unknowingly visit a malicious website, which is masquerading as a legitimate one, leading to a potential data theft or malware infection. DNS poison exploits the vulnerabilities in DNS systems to poison the cache with false information. So it could corrupt the cache data, manipulating the responses, or the resolver to part of the DNS that queries the server to resolve the domain name. Now, example could be a user, for example, trying to go to examplebank.com into the browser, but due to DNS poisoning, they are redirected to a fraudulent website that looks identical to the real bank, so you can't even catch it very fast that if it's the real website or a fake website, where the attacker would collect the credentials once you'll pass in order to log into the system. Then we have DNS hijacking. DNS hijacking is a malicious attack in which DNS queries are intercepted by an attacker, or the DNS server is compromised to redirect the user to a malicious website without their knowledge. It usually happens through a malware on a user computer by compromising a DNS server directly. The result is that the users are redirected to malicious website without their knowledge, even if they'll type the correct web address into the browser. The technique can be used to steal the information or to deliver the malware or to censor the information, etc. Its components could be intercepted queries, modification or redirection of a DNS request, or the malicious DNS server, a DNS server under the control of an attacker used to resolve the domain names to a wrong IP address. Example could be that when a user attempts to access a legitimate website, their DNS request is hijacked and inserted, and instead of getting a genuine IP address, the DNS server provides an IP address of a malicious website created to steal the personal information or to install the malware on the user device. Then we have DDoS attacks, which we call as distributed denial of service attacks. But before that, if we can consider that both DNS poisoning and DNS hijacking compromise the integrity of web applications, preventing these attacks requires a combination of secure DNS practices, including using DNSSEC to authenticate the DNS responses, maintaining a rigorous security standards on your DNS servers, and educating users about the safe internet practices. Regular updates and monitoring of DNS entries is also essential to detect and mitigate any sort of suspicious changes which are taking on your network. So now let's try to see that what is distributed denial of service attack. It is becoming very common, and we'll be exploring the distributed denial of service attacks, including a specific type of known attacks as amplified attacks, or we'll be understanding that how can these attacks can cripple your network by overwhelming them or by overwhelming the overall resources of your network. So a distributed denial of service attack occurs when multiple systems flood the bandwidth or the resources of a targeted system. Usually one or more web servers. Such kind of an attack is often the result of multiple compromised systems, for example botnet flooding the targeted system with the traffic. So the main purpose of a distributed denial of service attacks is to disrupt these services or make them unavailable by flooding them with excessive traffic from multiple sources. Now, this overload aims to exhaust the resources of the target system, such as the network bandwidth, server processing capacity, or the application resource, causing the slowdown or complete outages of the systems. The distributed nature of these attacks often involve in networks being compromised, computers or bots, etc., make them particularly difficult to mitigate and to trace that who are the actual perpetrators in it. Now, the components could be a botnet, as discussed earlier, or the traffic flood, etc. A network of computers that infects with malicious software and controlled as a group without the owner's knowledge is a botnet, and a traffic flood is a massive amount of the data sent to a server to overload it and prevent it from processing legitimate requests. Now, its example could be that an online retailer website is bombarded with tens or thousands of requests per second from multiple resources, overloading the server during a major sales event, which would make the website inaccessible to the legitimate users. If you want to see the practical demonstration of it, I have seen it on a video in my channel. It's called HPing3. So that's usually used in order to exhaust the resources of your targeted computers. Now, before we'll understand amplified attacks, if we look at the mechanism of DDoS attacks, the mechanics of a DDoS attack involves multiple compromised systems, which can include computers and other network resources such as IoT devices being used to launch coordinated attack sequences. Now, these attackers control their botnets through command and control servers, directing the flow of malicious traffic to the target. These attacks not only affect the direct target, but can also impact the intermediate network systems and services that are part of the traffic chain. So if we'll define the amplified attacks, these are DDoS attacks involves two attackers using the publicly accessible open DNS servers to overwhelm a victim's systems with DNS responses traffic. The process involves making the request to open DNS servers with spoofed IP addresses with the victim's IP, which then send large amount of data back to the victim's IP. For example, the attackers can use the network time protocol, which we call as NTP servers, to amplify their attacks traffic significantly. By sending small request packets to these servers, these elicit large response directed towards the attack targets, and the attacker can mitigate or can magnify the volume of the data to the target received by hundreds and thousands of times by the original amount. Now, this method is particularly insidious, and because of it leverages the legitimate servers to launch massive attacks with relative little input effort, and that would make sure, like the attacker would make sure that your network is completely crippled and you're not able to perform any operations on that. So the reflection could be a technique of bouncing the traffic off to the other DNS servers, or such as the NTP servers, to increase the volume, or increasing the volume of the attack by having the redirected traffic consist of large responses than the original requested value. So the example is then attacker sends a small query with a spoofed IP address to the target to open a DNS server, which then sends much larger responses to the target IP address. This is done using by multiple DNS servers, magnifying the traffic volume to the point where the target infrastructure is overwhelmed. Now, after this, we'll see some common scripting languages which are used in different kind of attacks. We have PowerShell, we have VBA, Python, and Bash. Now, we know that scripting and coding are powerful tools in the arsenal of a cybersecurity professional. However, these same tools can be weaponized by the attackers to automate and exhaust the attack at a scale. Now, let's try to understand in some of the most common scripting languages in these attacks, and how they are utilized and why their inherent capabilities make them the favorable choice for the adversaries. So if we look at the PowerShell, first of all, it's a task automation and configuration management framework from Microsoft consisting of command line shells and scripting language. Now, since it is built into Windows operating system and is incredibly powerful for automating the administrative tasks, attackers exploit the PowerShell because of its deep access to the system internals and the ability to execute commands across the network. It's often used in lateral movements within the network to carry out the actions without directly installing the malicious software. The typical use of the attacks is frequently to automate the systems used in executing or the malicious scripts, etc. Example is that the attacker uses PowerShell to download and execute remote access tool on a compromised system. Then we have VBA, which is also called Visual Basic for Applications. It's a programming language developed by Microsoft that is built into most Microsoft Office applications. Now, malicious VBA scripts are typically embedded into documents that, when opened, execute the code that can lead to downloading malware and other harmful actions. This is a common vector for phishing attacks, leveraging the trust users have in familiar documents and their formats. So commonly used to write macros that perform malicious activities in the documents. And example could be that an attacker can embed a VBA macro in a Word document that, when open, installs a malware on the computer. Then we have Python. It's a high-level programming language known for its clear syntax and readability. The simplicity of Python and the power it makes the ideal script for the network attackers by automating data breaches and more. Like, they can write different kind of scripts which would automate the attacks. Now, these scripts can be used to create tools and exploits to automate sending phishing emails, etc. As we are talking about that they are using for data harvesting and creating exploits. So the example could be that you can write a Python script to create botnets that would perform distributed denial of service attacks. Then we have Bash, and Bash is a Unix shell command language which runs on a text window and allows the user to execute commands by typing it. Now, we know that for Bash, it's a default shell on many Unix and Linux systems. Bash scripts are used for numerous malicious activities due to their direct control over the system functionalities and ability to execute complex commands chained together. This can include deploying malwares, controlling compromised systems, and even wiping the data on the detected drives. So it's used in scripts for malicious activities, files manipulation systems, surveillance, and launching the attacks. Example could be using a bash script to alter the system logs to hide the evidence of an intrusion, etc. Then we have ARP spoofing. Now, these kind of attacks are also called layer 2 network attacks. So we'll be looking at different vulnerabilities that can pose significant security risk to network infrastructures. We'll be understanding these vulnerabilities is crucial for network security, and it helps in implementing more robust defenses. So before we'll see that what are ARP spoofing or what is it, let's try to understand layer 2 vulnerabilities. Now, layer 2 of the OSI model is also known as a data link layer. Is a fundamental for the reliable transmission and data across the physical network. However, it is also present uniquely to secure the challenges that can be exploited by the attackers. We'll focus on three major types of attacks, which could be vulnerabilities of ARP spoofing, MAC cloning, and MAC flooding. So first of all, we'll be talking about ARP spoofing. It's a type of attack in which the attacker sends falsified ARP messages over the local network. This results in linking of an attacker MAC address with the IP address of a legitimate computer or a server on the network. So in a ARP spoofing attack, the attacker sends falsified ARP messages over the network. This allows the attacker to link the MAC address with the IP address of a legitimate device on the network, such as a computer or a server. As a result, the data is meant for the legitimate device can be intercepted or misdirected to the attacker. So the components could be ARP protocol used to map the IP network addresses to the hardware addresses used by the data, like link protocol, then falsified ARP messages that deceive other network devices about the true MAC address associated with the IP address. So every computer would have a unique MAC address. If you'll type in ipconfig/all, you'll be able to see the MAC address of your computer. So example could be an attacker uses an ARP spoofing to intercept the communication between two parties on a network, causing any data sent from the first party instead be sent to the attacker. Then we have MAC cloning attack. Now, in MAC cloning, an attack where the attacker emulates the MAC address to another device on the network, often to bypass the access controls that are filtered by the MAC addresses. So this attack involves emulating a copyright or copying the MAC addresses of one device onto another. Now, this can particularly be dangerous in environments where access control and network permissions are tied to specific MAC addresses. So by cloning the MAC address, attackers can gain unauthorized access to restricted network segments and the legitimate devices. MAC addresses are the unique identifier assigned to the network interfaces for communication on the physical segment. Cloned MAC addresses can be duplicate MAC addresses used to impersonate other devices. So usually our DHCP servers issues the IP addresses to the computers based on their MAC addresses. So if two devices would have the same MAC address, your DHCP server would issue the same IP address, and then they can use it for attacking purposes. So an example could be an attacker can clone the MAC address of a device that has an authorized access to the restricted network area to gain the unauthorized access. Then we have MAC flooding attack. In MAC flooding attack, this attack involves overwhelming the switch's MAC table with fake MAC address, forcing the switch to enter a fail open mode, which turns into a hub that broadcasts packets to all ports. So in a network switch typically maintains the MAC table that would map each MAC address to the corresponding port. So in MAC flooding attack, the attacker sent a large number of Ethernet frames, each with a different or a random MAC address to the switch. So the goal is to overwhelm the MAC table or to overflow the MAC table, forcing the switch to enter a fallback mode where it starts sending all incoming traffic to all ports, effectively turning the switch into a hub. This can lead to a traffic snooping and intercepting by the inception of the malicious actors, etc. So its components could be switch MAC table, a table that stores the MAC address and their corresponding ports to effectively or to efficiently forward the traffic. Excessive fake MAC addresses could be there that could false the MAC address sent to flood the MAC table. So an attacker floods the MAC table of a switch with numerous fictitious MAC addresses, causing the legitimate traffic to be broadcasted across all ports, potentially allowing the attacker to intercept the sensitive data, etc. Then we have advanced monitoring techniques. With advanced monitoring techniques, we can detect anomalies, recognize patterns and malicious activity, etc., and even predict the preempted potential threats. Now, it can be used to protect our network. So we'll have to understand different monitoring techniques that we have. We have anomaly monitoring, signature-based monitoring, behavior-based monitoring, or heuristic monitoring. So if we look at the anomaly monitoring, it's a method of detecting the deviations from the normal expected behavior of the network traffic to identify unusual activities that could indicate a security breach. Now, anomalies might indicate a security breach, such as an ongoing attack on the network or the malfunction of it. So by establishing what is normal, anomaly monitoring systems can flag unexpected behaviors, helping the security teams to respond swiftly to mitigate the potential risks. The example could be a network monitoring system flags an unusual high amount of outbound traffic, which is potential data exfiltration attempt, etc. Then we have signature-based monitoring. In signature-based monitoring, user predefined signatures of known threats to identify and respond to specific malicious activities within the network or the network traffic. So by comparing the network activity against the database of signatures, this technique can effectively spot and block the recognized threats. It's a vital tool for defending against known attacks vectors, but requires a regular update to remain updated with the latest threats in the market. So for that, we'll be using intrusion detection systems to detect the network request that matches the signature of a known SQL injection, etc., so that we can stop it in the timely manner. Then we have behavior-based monitoring. Now these analyze the behavior of the network traffic over the time to identify the activities that deviate from the established baseline or the normal activities. Now, unlike signature-based monitoring that looks for the specific patterns, behavior-based monitoring analyzes the behavior of the network traffic and nodes. This method builds profiles of normal user activities and network operations, making it possible to detect or indirect the threats zero-day attacks, or maybe the insider threats which do not match with the pre-known signatures but still deviate from the typical patterns. So if we'll be monitoring the tool alerts and the security teams when a normally inactive or the server IP suddenly starts sending the large amount of data, etc., we know that it's a deviating from the behavior, a normal behavior that we see on our network. Then we have heuristic monitoring, utilizes the experience-based techniques to predict or identify the potential threats by looking into the patterns that are out of the ordinary way or often using the machine learning algorithms. So it's not just about detecting the known threats, but it's also about the historical data and the patterns to predict and to prevent the future attacks. Heuristics can adopt over the time and learn from what the network encounters to continuously improve and improve its detection capabilities, etc. So example could be an adaptive security system adjusts the filtering criteria based on the learning from ongoing activities like zero-day attacks or the malwares before it causes a significant damage to your network. Then we have different essential security tools. In these tools, we have network analysis tools, flow analysis and NetFlow, data loss prevention, SNMP or log aggregation, etc., SIEM or SOAR. So these tools are really important in maintaining the security and integrity of the IT environment. So if we look at the network analysis tools, these are the tools which are designed to capture and analyze the network traffic to detect security breaches, troubleshoot the network issues, or to ensure the compliance and security policies. So in order to do that, we have different tools like Wireshark, TCPdump, or TCPreplay. Now, Wireshark is a network protocol analyzer. You might have used it for network troubleshooting and analysis of the communication protocol deployment, etc. Then we have TCPdump. It's a powerful command line packet analyzer tools used to display TCP, IP, and other packets being transmitted or received over the network, which a computer is attached, or TCPreplay, which is used to replay the captured network traffic. Then we have flow analysis and network flow or the NetFlow. These are the tools that can collect and analyze the IP traffic flow, which is particularly useful for understanding the type of the traffic on a network and identifying the anomalies in that. These are designed to capture and analyze the IP traffic flow, helping the organization understand the traffic patterns and network usage. By analyzing the flow, data administrators can identify the anomalies, optimize the network performance, and can detect the security breaches based on the irregular traffic patterns. So it's a protocol which was designed by Cisco to collect the IP traffic information and monitoring, etc., and network flow, etc. Then we have DLPs, which is data loss prevention systems that help detect, prevent data breaches by monitoring the data usage and preventing unauthorized access or transmission of sensitive information. These systems are crucial for safeguarding the sensitive data. They work by identifying, monitoring, and protecting the data in use, in motion, and at rest. So DLP solutions help prevent the data breaches by defining the policies so that if we have defined or marked a document as confidential or highly confidential, it won't let you copy the document in a USB file, attach it in the email, or share it on the network. So the systems constantly monitor the kind of security policies which are there on those documents. Example could include a software solution that monitor and detect the data in rest, use, and in motion across the network endpoints. Then we have SNMP, log aggregation, etc., and SCAP. Now, these are the tools used for network management and security reporting. These help in collecting, analyzing, and archiving the logs and security data. For that, we have SNMP, which is Simple Network Management Protocol used by network management. For example, we are using it in order to collect the logs of the devices, printers, and devices which are connected to the network and their health status, etc. Log aggregation tools can collect and consolidate logs from multiple sources for analysis. And SCAP is the security content automation tool, which are the standards for employing and automating configuring vulnerabilities and patch checking and security measurement, etc. In the end, we have SIEM and SOAR systems that are designed for advanced threat detection, systems management, and automation response and security incidents. So if we look at the tools like SIEM, which is the Security Information Event Management, it provides real-time analysis of the security alerts generated by applications and network hardware, etc. Whereas SOAR, which is Security Orchestration, Automation and Response, automates the responses to cyber threats to improve the speed and efficiency of security operations. Now we have different set of problems or the threats which are related to emails. Email is a fundamental tool for communication in any organization, but it is also a common vector for cyber attacks. The challenges in email security include phishing, scam, malware distribution, and direct attacks on email servers, etc. So first of all, we look at the most common kind of attacks, which is on the emails, and we'll try to understand that how can we make sure that the emails are not being compromised, or we are managing it in a way so that they cannot become a very important tool for any attacker. So email threat encompasses the variety of malicious activities aimed at compromising email communication to steal sensitive information, etc., or malware or conduct fraud, etc. So we have different forms of it like phishing, spear phishing, malware distribution, and spam. So if we look at the phishing, it's the deceptive email pretending to be from a reputable resource to steal the information. For example, you could receive an email from someone saying that your account has been compromised and you need to change the password. So click here in order to change the password. So once you'll click on that link, instead of taking it to the right place where you change the password, it would redirect you to a lookalike website. And once you'll enter the username and password, it would be captured by that party. Then we have spear phishing. That is targeted attack aimed at the specific individuals or companies. We talked about it in detail in our module number 1. Then we have malware distribution email carrying the malicious software, and spam, which is unsolicited junk email, often for commercial purposes. After that, we have sender policy framework. It is an email authentication method used to prevent spammers from sending messages on behalf of your domain. So in order to protect our flow of the emails and making sure that it is used for the right purpose, we have DNS text records, which publishes that which mail servers are authorized to send email on behalf of the domain. For example, a company can configure a SPF by adding a DNS text record that specifies only the mail server with the IP address designed by the company which can send the emails from the company domain. After that, we have domain keys identified mail, which we call as DKIM. It allows the sender to associate the mail name or the domain name with an email message, thus the vouching for its authenticity via cryptographic authentication. So your DKIM provides a way to validate the domain name identity that is associated with the message with the cryptographic authentication, etc. It uses a digital signature linked to the domain, thereby helping to ensure that the content is not altered in transit. Its component could be digital signature, since we are verifying it by the cryptographic authentication. So it's attached to the email header by encrypting against the public and private keys. Then we have the DNS records, which are used to public key and decrypting the signature. So an email sent from a corporation server is signed with a digital signature. The recipient server uses the DKIM DNS record to decrypt the signature and to verify the email source. Then we have domain-based message authentication, reporting, and conformance. We call it as DMARC as well. Now, DMARC is a protocol that uses SPF and DKIM, like the previous two things that we have covered, in order to determine the authenticity of an email message. So DMARC is the policy that allows the domain owners to specify how email receivers should handle the non-aligned emails and provide an extra layer of defense against the email spoofing, etc. So its policies, it could be done by the policy enforcement by decide that how to receive the server and handle the emails that fail the SPF or the DKIM checks, or reporting inform the sender instances where the emails are rejected or marked as spam. So the example could be a company sends a DMARC policy instructions email providers to reject the emails that fail SPF and the DKIM checks, significantly reducing the risk or spoofed emails which are being accepted. And in the end, we have a topic which is secure email gateway. And a secure email gateway is a point at which the incoming and outgoing emails are scanned for malicious content and prevented from entering the network. So for that, we use appliances which could be physical or could be a cloud-based service that monitors the email and blocks the malicious content and even prevent the data leaks. Now, these gateways uses a variety of threat detection techniques to analyze incoming and outgoing emails for signs of phishing, malware, and email and other sort of attacks. So they can act as the spam filters, blocking the unsolicited or unwanted emails which shouldn't be there, or the virus scanners which check the attachments and the links for the malware. So example could be an organization appliance for SEG, which is secure email gateway, intercepts an incoming email with an attachment that contains a known virus, so it can prevent it from there so that other recipients in your organization will not receive it. So that was on our lecture on information threats and security monitoring.